Hey, a warm welcome back to the Information Security Stack together with me, Daniel Gustafsson and Kim Hindart.
Hubba.
Today, Kim, we will look at an application and we were going to start to dissect an application and what it actually, how do you actually build one and what is actually, how it's actually structured. And the reason for this is that we need to, or at least we believe that we need to, inform the audience a little bit about the actual technology behind an application and how it actually works. This is relevant for everyone that is supposed to make a decision about an application or a decision about a new technical system, or just overall have a better understanding of how does an actual application communicate. So this is us trying to very high level explain how this works. And yes, this might be super obvious for some of you who are listening to this, but it might be news for others. So bear with us. Where do we start, Kim?
Yeah, why is this important in the first place for people to understand? And especially if I'm a developer, why should I still listen to this actually?
Well, I believe you should listen because it's good to get an understanding for other people's point of view as well, not only your point of view. If you are a developer, you know exactly how to develop an application and the back-end functionalities behind it, but you need to communicate and relay this to other people around you who might not be developers. So it's good to get another point of view.
And it's good to get perhaps some type of idea how you can explain this to managers as well, because I mean, if you do want them to take you seriously and understand why it's important, what you want to get funding for, it's good also to understand if they can understand a bit reasoning behind it. So anyway, hopefully this will be something useful for everyone. So let's start with an application then. We'll start with something that processes digital information. So let's start with an application is something that takes an input out of something. Something comes into it in a digital way. So a digital signal of some type comes into the application. The application processes it and sends an output of some kind.
Yep.
Let's take a good application example that everyone knows. Oh, this is really what I think of an application. When you think in your mind of an app, okay, you go into your car and you put your foot on the accelerator and push it down.
Yep.
That's a user interface. Because a user, a human user in this time, sends an input to an application. And that application is then translating that input from I put my foot on the accelerator and push it down to an output that goes to the carburetor, the fuel injectors and stuff to provide the right amount of fuel for the car to move forward.
But I thought that it tugged on a gas wire and then the carburetor opened and like they didn't know good old days.
Manual throttling, absolutely, you have that. But guess what? In a modern car, try and find the manual ones there. No, what happens?
Fair point.
Yeah, you translate what happens when you push the pedal with the foot to a digital signal that goes into the computer in the car. And the computer then translates it to output and sends it to the different relays that actually regulate fuel and fuel injection and throttling. So if you have a car made after 1990 sort of, and up till now. So if you have a decently modern car.
So what you're saying is there's a computer in my car.
Yes. And not even that. There's several hundred or even several thousand computers in your car nowadays. So, yeah. So that's it. So just to blow your mind, you could just as well today drive your car with a hand controller, you know, the kids sit on.
The PlayStation 1 or the Xbox ones,
It would be perfectly just as fine to drive the car, because this car is expecting a digital input that it translates to driving, steering, So guess what? When you turn the wheel on the car, it's not a mechanical connection to the actual wheels in the front that actually turns when you turn the steering wheel.
Modern things. I really wanted to be an old-fashioned steering wheel turning the actual wheels through, but that's not the case anymore. Okay, fair enough then.
So yeah.
So why do we still continue to do that then if we don't have to?
It's an interface we're used to.
Ah, gotcha. Fair point.
So that's just the main. But to be perfectly honest, you could just as well have a hand controller today and steer the entire car. So accelerator, an application.
Yep.
Steering wheel of the car, an application.
That
was everyone's first sort of an application when I.
Exactly. What's an application? A steering wheel and an accelerator on a car.
But still, we are back to the basics. Input of some kind, output. And how you provide the input is the interface. And if a user is providing that, it's a user interface. But let's take something more digital then. Let's take a web shop. You go to buy stuff on Amazon. Now, you're more normal, what we call a graphical user interface. It's not point and click or a button or something like that. That also could be an interface. Let's remember that, for instance, your microwave have an interface. That's usually buttons. If you haven't heard of a really, really modern microwave with a touchscreen connected to Twitter, with but,
and so on and so forth.
So on and so on. I got a toaster with a online Twitter account directly connected.
Oh, of course you do. Because
so I got a tweet when the code is ready. So yeah, because that's really necessary. So anyway, but how you interact with stuff that then uses something digital is called an interface. So it might be physical buttons also. We shouldn't forget that. But normally a mouse and keyboard and something graphical on a screen is what we expect today on the app side. And even if we go so far to the phone era, we have a touch screen. That's our interface. But it's still things on the screen you press and point with your finger. And then stuff happens. So what's happening behind this? Yeah, you can base down any digital operation connected to storage. And as we've tried and explained earlier, you need compute, you need network, and you need storage. But any operation to storage in an application can be based to 4 basic principles. And this is true for any type of application, even if you call it a game, or if you call it a steering options, or if you call it, you have 4 basic things connected to persistent storage if you need that. And that's CRUD. Yep. Create, read, update, and delete.
Yes.
It's create, read, update, and delete only. And that is the secret with all and everything digital in an application way. Imagine a game, even a hand-controlled PlayStation game, you play. It's still a progression you make.
Yeah.
So it saves the state you're doing. And it reads stuff, sends it out as an output to your screen. So you see what's happening when you're playing. So it takes input from your hand controller, sends output to the screen based on your input, and it reads from the storage, and then actions you do in the game through your input has an effect.
Yep.
That it's then also updated. So it updates. It reads, it updates. It even creates data. When you want to save a file, it creates data.
Yep.
You might want to remove a save file, then it deletes data.
Yep.
So all the 4. Create, read, update, delete. CRUD.
That's the principle we base it on.
Even if it's a game, or if you do make an online purchase at Amazon.
Yep.
It's still create, read, update, and delete. So what's the first thing they want you to do with Amazon?
Create an application. I was almost saying application. I want to create a user. Otherwise, I can't use Amazon. Exactly.
You need to create a user account. So, of course, then you create it. But then you move and you need to change address. Now they want to update your record they have of you as a user.
Yep.
And now you want to remove a credit card that's expired. Now they delete records connected to your user. And then you place an order, of course. Then you create stuff, and you might even want to read stuff later on. Because, as I said, entire browsing of the web is reading data. When you watch Netflix, you read data a lot.
Exactly.
So it's still the 4 basic principles, and that's anything digital. So create, read, update, delete. And you interact through that to different interfaces that gives an input, and then you get an output. And it might, of course, be like now we sit on a video link with talking to each other, or you might get to watch a movie, see a picture, play a game. So anything, including you might get throttling to your car engine and driving. Or even the pilot flying the plane.
Yes, fly-by-wire it's called. So you see a pilot turn the knobs and levers and steering wheels and throttles and everything in the cockpit, but when they do that, there's actually nothing happening in the back end other than an input to a computer that then sends the output to the systems, and then the airplane either turns, accelerates, brakes, or whatever function they want to initiate. Fly-by-wire, it's called.
But you don't have a direct connection from the controls.
Not anymore. No, the ailerons and so on and so forth is not connected directly to anything.
The Wright brothers had direct connections between
They
flaps,
literally
the wings, and
they literally pulled the lever, which then pulled the line, which then actually then hopefully, if they were lucky, turned the airplane the way they wanted to. Exactly.
But that's not done today.
No.
Just to be clear.
No.
So that's the baseline and the basic understanding of an application. And why we're trying to tell you this, because you have a lot of discussions, a lot of different ways to make this. You have a lot of storage options. You have a lot of database options, because how you store stuff is important. You can store it in what's called a relational database. That's a table. We as humans like tables. It gives us a good overview and it's easy to understand. So there's a reason why we like tables. We actually genuinely like tables. If you print a magazine, believe me, tables, regardless of what's in the table itself, will get attention. So we like tables. And that said, that of course it's nice and structured. Let's take a good example. Name, address, and zip code, just to deliver stuff. And you put, if you have plenty of records with plenty of different names, with different address and zip codes, like for instance a customer register that you send stuff to, Amazon's people that's ordered, there's plenty of names and records for that one. Okay, so I have my record for my home address and my zip code. And what we like with a database is this is structured. Why do we like this with the relational thing? That the relational part is just the table we're talking about. But why do we like this?
Well, it's easy to read, isn't it? It's easy to understand. The brain can compute the information.
And it's nice when it's structured, because if I just put up a table where you can write stuff, I usually do this when you have a form with pen and paper. And it annoys people to no end. For instance, we had this ledger that you put in when you were a visitor, sign or visit book or greeting book. And then they asked for name, address, and zip code. And then, of course, I put my name in the zip code column. And I put my address in the name column just to...
Of course you did.
Mess things up. But in a computer world, you can easily validate stuff. So if I try to do that in a modern form, try and do that on Amazon's registration form. And you will get an error that says, no, we can't accept this input because that's wrong. You're obviously not putting a zip code in the zip code form.
No.
So that's nice enough. So you can have that. But then you want to have a database behind it. And as many ask then to develop apps. What's the best database in the world? I want one single answer of the best database for everything I need to do in now and in the future.
Yeah. And the answer for that is it depends.
Yeah, or there are no unicorns.
No.
It's like asking, I need the best car for all my potential needs in the future. The very best car. And if there were the very best car who can have the best fuel efficiency, cost the least, and work as a Ferrari in one instance and as a truck that can take and shuffle tons of goods in the other instance, depending on your need, and it can fly over car queues. Everyone would use that.
Yeah, we wouldn't need any other cars.
There wouldn't be no other brands.
No.
Everyone would use that car if all of these were true. But
do you want the green one, sir? Yes.
Unfortunately, guess what? That was true in one era, one time of actually the last century, and that was when Henry Ford made the T-Fords. But that was the one and only and last time that cars happened. So, yeah.
But to your point, there is no unicorns in terms of databases. You need to look at your specific needs.
So there's different databases, a lot of different names, a lot of different options out there. And this makes building an app complicated because guess what? There's a lot of different components you might use, you might even want to use. And then to blow everyone's mind, you have this relational database. Then you have the non-relational database. They're even called NoSQL database. Because SQL databases are synonymous with having relational databases.
So a SQL database is a structured database where you can remove things, right? And you can restructure and you can remove. So with a NoSQL,
it's still part of a structure in some instances. So that's true. But imagine instead of having update and delete on records, you remove the update and delete part and only read and create. So the only thing you do is push new records and read them and then create new, and you store everything else. Why does this make sense?
Yeah, why does it make sense? Because doesn't a database where you don't remove anything, you just add records, doesn't that become really, really, really big?
Exactly. It becomes really, really big. But the important part is it becomes really, really fast as well. Because from a computer point, finding my specific record takes lots of CPU power. Crazy amount of CPU power. Because finding a specific record, let's say I want to update my address information. In a SQL database, they would have to find my specific user and make sure that it was my specific address information that were updated, because they didn't want to update anyone else's, of course. So, and just searching through the table and finding that is a big thing. So that's why you tend to want to keep tables small. How do I find my correct record in a NoSQL instance? Yeah, you just look for the latest one. Every new record is timestamped. So even though I might have earlier updated things, they just look for the timestamp, search chronologically back in time, and find the first one they find. That's the latest one. That's the one that they put as my current address.
So to give the listeners a couple of names to what is a SQL and what is a NoSQL. So popular SQL databases, which are they?
Microsoft SQL, MySQL, MariaDB, Oracle is popular SQL. SAP is a popular SQL relational database. NoSQL is MongoDB, CrouchDB, and a few of those. So
so there are variations, and maybe you can relate to them if you heard anyone talk about them. There are differences between them.
Yes. So you have difference, but like I said, none are the best at anything. That's the important part. You can have a NoSQL application, and then that costs you a lot of storage, but a lot less on the compute power. On the other hand, you can have a SQL database that costs a lot more compute power, but a lot less on the storage. So,
okay,
these are the things, of course, that's important. So yeah, you have different use cases, and they're good at different things. So that's why you might, for instance, in a modern app, need both of them. And then you have, of course, file storage. Imagine you have a computer with a file folder.
Yep.
You can put pretty much anything into that folder, anything from documents, video files, pictures, music files. It's open for anything in a file structure. And this might also be something you need in your application. But imagine if you have a file structure in a folder on your computer. You still interface through the computer's operating system, through the computer's user interface. But it's still the same. Create, update, and delete.
Same principles.
Create, read, update, delete. And that's back to the same principle. So that's what's shortly and an overview. Hopefully everyone could follow and understand this, because
Yes, but it is important, and again, even though if I'm not a developer, it is important to understand A, what we're doing, B, what we are building, how it works, and if we're going to make any changes, structural changes, or investing in new systems or whatever it might be. I mean, of course, I can just blindly trust Kim that whatever he says is true, and I'll purchase whatever he decides that we should bring into the company. But there's a benefit to understanding technology that you're using currently. So it's not just an app in a phone or an app on a computer, and I click in the app and things happen, and then I just lackadaisical don't care about what is then happening behind in the back end of things. But there's an absolute relevance to start to communicate between each other and understand what it is we actually are trying to build, how it works, if we're going to invest something new, what are we going to buy and why.
And so let's finish this episode with the baseline then. How do you actually make all of this happen when you want to do something? You need to program. How do you program? Yeah, as we've said, computers can only read things in binary. They can only read things in ones and zeros. But me as a developer, we as humans need to be able to write something. That's why we write a program.
Yep.
You have a specific syntax that can be translated to normal language as grammar. If you put things in the wrong grammatical order with the correct words, but you put them wrongly, the meaning you want to say to another human might not be correct.
Nope.
It might be different. So, yeah.
Might be completely misinterpreted.
Exactly. So that's why grammar is important, to get the correct meaning to it. And this is called the syntax of a computer language. And it's the same here. What's the best computer language? I want one computer language that's best at everything.
Again, it depends.
Yeah, so no, there's no best one. I usually recommend do the one you're most familiar with, because if you're writing a book, write with your native language, otherwise it will be harder. But yeah, so this is authoring. So then you translate this computer language to this programming language to computer language, that's ones and zeros. That can do. And then this program can either ask for inputs in certain areas, respond to the input, and then process it correctly, and then you use CRUD to store the data it does. So that's easy what you do in a computer program. So that's how you do it. But no such thing, unfortunately, as the one best language as everything. And then you have, even to complex it more, you have directly interpreted languages, a script we call it. That's when I write and press run, and it runs immediately. then you need to have installed a program interpreter. Otherwise, you can compile the language. That's another type of languages that you have to compile first. Java, C is popular those. And when you have compiled it, you get a program file that you run. You get the small, as you've seen, for instance, app icon, and you click it and then run it. Then you get a program file. And that means that it needs to pass a compiler to translate that to machine code. There are humans who can directly program machine code, but there are very few in the world. So usually use a program language instead, and then let an interpreter change this to computer language. But the source code, it's the center. Then it performs CRUD, and that can be stored as files, and then you have a lot of different storage options, and they can store in databases, and then you have a lot of different database options. But those are the baselines if you dissect an app. And yes, I know now we will get horrendous complaints from the programmers that I missed a lot, but I try to keep this because you can talk for this for hours and days. There's even engineering programs several years just with this. So yeah.
This was the basic high-level discussion. Again, we're just trying to get people informed as to a very basic level. But yes, we left a bunch of things out that are relevant in how to write the code or write an application or write scripts or whatever it is. But it is just the difference is the terminology. You can't just run around talking about scripts and Java or Python or C or whatever, which other language you like to write in, and automatically hope that everyone around you understands what you're talking about. So again, trying to get this point across that we want this podcast to be a communication bridge between the technician and the decision maker and the lawyers and everyone around you. That is important because we need to start to communicate with each other. So very high level on how an application works in order for this to make sense moving forward. Now, we will probably talk more into details moving forward, or we might even bring people in who will talk about this more in detail in the future, which is, I think, is going to be beneficial as well. But there you go, dissecting an application on a very top level, how it's structured, what it needs in order to work. And how do you actually write it? We can talk about them separately.
And please remember that when you put your foot on the accelerator pedal,
yes,
you're running an application. Just keep that in mind.
Exactly. Your car is an application, essentially.
You're using an app.
So that's that on that. If you have any opinions about this, if you want to know more, you know where to reach us, citynetwork.eu/podcast. If you want to check us out on social media, you can. You can also find us on YouTube and so on and so forth. So until next time, Kim, have a great week or weekend, depending on when you're listening on this. Take care.
Hubba.